In August 2024, the James Webb Space Telescope did something it was never designed to do. It turned away from the distant universe and pointed at the closest sun-like star to Earth, Alpha Centauri. What it captured in that image made astronomers stop everything. A faint point of light, sitting exactly where a planet should never survive. But that's not the disturbing part. When scientists went back to look again, it was gone. Not moved, not dimmed. Gone. And the explanation for why it vanished, and what happened when researchers finally looked again this year, might be one of the most genuinely unsettling stories in astronomy right now. For over 60 years, astronomers have quietly obsessed over one specific point in the southern sky, not because it's the brightest object out there, but because it's the closest. Alpha Centauri is a triple star system in the constellation Centaurus, and its two main stars, Alpha Centauri A and Alpha Centauri B, sit just over 4 light years from our solar system. According to NASA's own mission reporting, in cosmic terms, that's not a distance at all, that's the house next door. And for decades, we've been staring at that house wondering one simple thing. Is anyone home? Despite being our closest neighbor, despite astronomers having confirmed nearly 6,000 exoplanets across the galaxy by now, Alpha Centauri A, the star that's almost a perfect twin of our own sun in size and age, and the third brightest star in Earth's night sky, remained a locked vault for decades. Proxima Centauri, the small red dwarf in the same system, already has 3 confirmed planets. But every serious attempt to find a world around Alpha Centauri A, specifically, had ended in frustration, false alarms, or silence, according to Stewart Observatory's own reporting on the research. The problem was never distance, it was light. Alpha Centauri A and B are so bright, so close together in the sky, that even the most powerful ground-based instruments drown in their glare. Researchers involved in this project have compared the challenge to trying to spot a firefly hovering next to a lighthouse from hundreds of kilometers away, while the lighthouse itself is moving. For generations of astronomers, this was considered one of the most brutal observational challenges in the entire field. Aniket Sanghi, a Caltech PhD student and co-author on the eventual discovery papers, told Scientific American he specifically sought out Alpha Centauri A precisely because it was one of the most difficult targets he could find to work on. Then came the instrument that finally cracked it open. The James Webb Space Telescope, the largest, most powerful space observatory ever launched, was designed and optimized to find the most distant galaxies in the universe, objects billions of light years away at the very edge of observable time. Pointing it at a star 4 light years from Earth was, in a real sense, using it for something it was never primarily built to do. The operations team had to design a custom observing sequence specifically for this one target, according to reporting from Astronomy magazine, with no standard playbook to follow. In August 2024, they made the attempt. Webb's mid-infrared instrument, MIRI, deployed a coronagraphic mask, a device that physically blocks the blinding light of a star directly over Alpha Centauri A. Even that wasn't enough on its own. Light bent around the edges of the mask, creating ripple patterns across the image. The telescope's own mirrors and support structures introduced their own interference, and Alpha Centauri B, the second star in the pair, poured its own contaminating glow into the frame. So the research team built a digital model of the contaminating light from both stars and subtracted it layer by layer, according to Astronomy magazine's detailed breakdown of the process, essentially digitally cleaning the image until whatever was actually there could be seen clearly. What emerged was a single point of light, more than 10,000 times fainter than Alpha Centauri A itself, sitting at a separation of roughly 2 astronomical units from the star, according to the peer-reviewed paper published in the Astrophysical Journal Letters. The team labeled it S1, and if S1 was real, it wouldn't just be another entry in an exoplanet catalog, it would be the closest planet to its host star ever directly imaged in human history, and the nearest imaged world to Earth itself. But before anyone could get excited, the team had to answer a genuinely difficult question. What if it wasn't a planet at all? A faint smudge in a heavily processed image can be almost anything. A background galaxy photobombing the frame, a passing asteroid, or an artifact created by the detector itself. Astronomy has a long history of these phantom detections, quietly destroying otherwise promising research careers. So the team, according to the published methodology in their own papers, ran round after round of deliberate tests specifically, designed to rule out S1, to prove it was a glitch, a galaxy, anything ordinary. One by one, according to the team's own published findings, every mundane explanation failed to account for what they were seeing. That left only one real path forward. Go back and look again. If S1 was a genuine planet, it should still be there moving, predictably along its orbit. In February 2025, using valuable director's discretionary telescope time, the team turned Webb back toward Alpha Centauri A. They found nothing. The point of light had vanished from the exact region of space where physics said a planet should be. Before we get into what that disappearance actually means, and why a second and third failed observation didn't end this story the way you'd expect, I want to know, if you were on this research team and your history-making discovery vanished the moment you tried to confirm it, would you have kept looking or moved on? Drop your answer below and subscribe now, because section 2 is where this mystery gets genuinely stranger. The team didn't panic after that first failed follow-up in February 2025. Orbits are complicated, and a single missed observation isn't necessarily the end of a discovery. So in April 2025, they looked a third time. Nothing again. Now stop and actually sit with what that means. The most powerful telescope ever built had captured an object next to our nearest sun-like star, an object that passed every single test the team could throw at it for being real. And then that object simply stopped appearing. Rewind to 2019, years before Webb ever pointed anywhere near this system. A team led by astronomer Kevin Wagner, using the European Southern Observatory's Very Large Telescope in Chile, detected a candidate object near Alpha Centauri A, labeled C1, first reported in a 2021 paper published in Nature Communications. It appeared at roughly 1 astronomical unit from the star, but skeptics argued it could just as easily be a cloud of dust or an instrumental artifact. The detection faded into scientific limbo, until researchers laid that 2019 sighting next to the 2024 Webb detection, and a genuinely compelling pattern emerged. In 2019, an object of a certain brightness appeared on one side of the star. In 2024, an object of comparable brightness appeared on the opposite side. Wagner explained the significance directly. When all you have is a dot of light next to a star, you may or may not be looking at an actual planet, but when you see a dot of the same brightness several years later on the opposite side of the star, the story becomes much more compelling. So the research team, which by this point included Caltech's Aniket Sanghi and Charles Beichmann, executive director of NASA's Exoplanet Science Institute, built simulations covering millions of possible orbits. They factored in the original VLT observation, all 3 rounds of Webb data, and one genuinely difficult constraint. Any viable orbit had to remain gravitationally stable in the presence of Alpha Centauri B, the second star in this tight binary pair. The result was a single plausible world, a gas giant roughly the mass of Saturn looping around Alpha Centauri A on an orbit lasting somewhere between 2 and 3 years on a stretched elliptical path with roughly a 0.4 eccentricity value. And here's the detail that makes the entire mystery collapse into place logically. In a meaningful share of the simulated orbits, the planet would have swung close enough to the star during February and April 2025 that Webb's coronagraph physically couldn't have distinguished it from the star's own glare. The 2025 attempts were simply unlucky timing, catching the planet while it had slipped in front of or behind its sun. In August 2025, the findings were formally accepted for publication as 2 companion papers in the Astrophysical Journal Letters. Wagner, who'd been chasing this specific ghost since 2019, called it one of the most exciting results in astronomy of the decade. Now, here's the part of this story that most surface-level coverage tends to skip past entirely. This candidate planet, if it's real, sits inside Alpha Centauri A's habitable zone, the specific region around a star where surface temperatures could theoretically allow liquid water to exist. For decades, that phrase has carried something close to humanity's deepest hope about our nearest neighboring star system. This discovery, if it holds up, may complicate that hope significantly, because the object sitting inside that habitable zone isn't a rocky world at all. Its mass sits somewhere between 90 and 150 times the mass of Earth, with a radius comparable to Jupiter's. That's not a planet with a surface to stand on. That's a crushing sphere of gas, with no oceans, no continents, and nothing resembling solid ground anywhere within it. Before we get into exactly why a gas giant sitting in that specific location might mean something much bigger for the entire habitable zone around our nearest solar twin, I want your take. Does knowing our closest sun-like star's habitable zone might already be occupied by an unlivable gas giant change how you think about humanity's long-term prospects of ever reaching a second? Earth nearby? Drop your answer below and subscribe now, because section 3 is where the story gets into genuinely disturbing territory. Let's sit with what a gas giant occupying Alpha Centauri A's habitable zone actually means, because the implications go well beyond just no second Earth here. According to the research team's own published analysis, the planet's highly elliptical orbit sweeps through most of the habitable zone repeatedly, every 2 to 3 years. Aniket Sanghi described the consequence directly. A planet like this would make it unlikely that smaller rocky planets could survive there at all, its gravity clearing out anything Earth-like the way a bowling ball clears its pins. If that assessment holds up, it means the habitable zone of the closest sun-like star to Earth isn't a peaceful, empty region, patiently waiting to be discovered. It's a demolition zone, a stretch of space where any rocky world that might once have formed there was either destroyed, gravitationally devoured, or flung into interstellar darkness. Here's the second disturbing layer, and for scientists studying planet formation, it might genuinely be the bigger one. This planet, according to everything we understand about how planetary systems form, probably shouldn't exist at all, at least not where it's sitting. Alpha Centauri A and B are two closely separated stars locked in a tight mutual orbit, a genuinely chaotic gravitational environment. Our best existing theories of planet formation generally hold that building and keeping a massive gas giant stable in that kind of environment should be extraordinarily difficult. Sanghi told NASA directly that the planet's very existence in a system of two closely separated stars would challenge our understanding of how planets form, survive, and evolve in chaotic environments. If this candidate is eventually confirmed, it forces a real, substantive re-examination of planetary formation theory and binary star systems. Now, let's be genuinely intellectually honest here. The scientific community has explicitly not stamped this discovery as confirmed. The research team themselves acknowledge that with only a single robust Webb sighting, the candidate cannot be unambiguously confirmed as a genuine planet without additional observations actually tracking its motion over time. Eric Agol, an astrophysicist, not directly involved in the research, praised the underlying work, but specifically cautioned that it remains too early to definitively call this object a planet. Elizabeth Matthews, an exoplanet-focused astrophysicist at the Max Planck Institute for Astronomy, offered a similarly careful framing. If it's real, it's amazing. The evidence, taken as a whole, is genuinely strong. But in serious science, almost certainly is meaningfully different from certainly, and that razor-thin gap is precisely where this entire story currently hangs. Here's what makes this particular mystery genuinely different. This one has an actual date attached to its resolution. Based on the ASO team's own orbital calculations, researchers have already calculated the next specific window when the planet should swing back into a position where Webb could observe it directly. August 2026. That's not a distant, hypothetical future event. That's now, or within the very next few weeks of whenever you're watching this. Wagner has stated plainly that this specific window represents the best opportunity to confirm the planet's identity beyond reasonable doubt. If the dot reappears exactly where the model predicts, the case effectively closes, and a genuinely new world enters the history books. And if it isn't there again, we're left with something arguably even stranger. Two separate telescopes, 5 years apart, both independently detecting an object that survived every test thrown at it, yet somehow continues to evade being definitively caught. Before we bring this all together in the final section, tell me, given that the resolution to this exact mystery could genuinely arrive within weeks of you watching this, are you rooting for confirmation, or do you think the more scientifically interesting outcome would actually be another disappearance? Drop your answer below and subscribe now, because the final section brings together everything this discovery could mean. So let's bring this entire story together, because whichever way August 2026 resolves this specific question, this discovery has already changed something real about how astronomers think about our nearest stellar neighbor. In August 2024, using a custom-built observing sequence never before attempted on this specific target, Webb's mid-infrared instrument captured a real, statistically robust point source next to Alpha Centauri A. That detection, labeled S1, aligned closely enough with a separate 2019 detection from ground-based telescopes in Chile, labeled C1, that a team spanning Caltech, NASA's Jet Propulsion Laboratory, and the University of Arizona built a full orbital model treating both as the same object, one that fits the observed data cleanly and explains why two subsequent 2025 observations came up empty. That work was accepted for publication in the Astrophysical Journal Letters in August 2025, one of astronomy's most rigorously peer-reviewed venues. What remains genuinely, honestly unconfirmed deserves equal weight. A single robust detection, however carefully vetted, is not the same thing as a confirmed planet with a fully verified orbit. That's exactly why August 2026, right around when you're likely watching this, matters so much. The team's own orbital modeling puts the planet back into an observable position relative to its star during this specific window. Webb won't be working alone on this question for much longer either. NASA's Nancy Grace Roman Space Telescope, scheduled to launch by May 2027 and potentially as early as fall 2026, carries dedicated hardware specifically designed to search for hidden worlds around binary star systems, exactly like Alpha Centauri. Charles Beichmann himself described what this candidate would become if fully confirmed: a touchstone object for the entire field of exoplanet science, studied repeatedly by observatory after observatory for decades to come, precisely because it sits closer to Earth than any other comparable discovery ever has. Here's the honest, complete picture to leave you with. We now have strong, peer-reviewed evidence pointing toward a genuine giant planet orbiting our nearest solar twin, sitting in a location our current planet formation theories say it probably shouldn't be able to survive. If confirmed, its presence would mean the habitable zone of the star, most similar to our own sun, is far more likely to be a chaotic, cleared-out region than a peaceful cradle for rocky worlds. For 60 years, we assumed our nearest stellar neighbor was quiet because it was likely empty. This discovery, whether it's ultimately confirmed this August or the mystery deepens instead, suggests a different possibility entirely. That we simply weren't capable of seeing clearly enough what was actually there all along, hidden not by distance but by the overwhelming glare of the very stars we were trying to study. I want to hear where you land on this. Given everything we've walked through, do you think Webb confirms this planet when it looks again this August, or do you think this becomes one of astronomy's great unresolved mysteries instead? Drop your prediction in the comments. I read every single one. And if this breakdown gave you a clearer, more complete picture instead of just the sensational headline version, do me a favor. Hit subscribe, tap the notification bell, and share this with someone who'd want to know we might already know exactly when we'll find out the truth. Thanks for watching, and I'll see you in the next one.